So we're going to look at how do we word the conclusions once we get our confidence interval out, and also how to find those critical z-scores given different levels of confidence. So this example where we're going to look at some different ways to word the conclusions and what's a good way, what's a bad way, is using the confidence interval that we just worked through in our example. The exact interval that we got out was 46.04 up to 49.96, and that interval gave us exactly 95% confidence. This problem below is using rounding to 2 decimal places. In general, we do want to keep all of this information, the basically 4 decimal places during the calculations. So in this question, they're using the interval 46 to 50 for the confidence interval. So just keep that in mind here. But if we were using exact wording, we would want to use those values. So I'll probably insert those once we get to questions using those numbers. So with that, we get this lower bound, we get this upper bound, and the key to the wording that we want to bring through is that lower bound and upper bound is for our population proportion. So that's a lower and upper bound for whatever P represents. And that's what we want to bring through in our wording. So with that, we're not talking about P hat anymore. Our sample size doesn't matter, the sample data doesn't matter. That's just a starting point to get to these values for P. So in our wording, we're going to have 3 pieces that we need to talk about. A very important piece is our level of confidence. So stating level of confidence is important because there is an only certain percent chance that we're accurate here. And there's also a percent chance that we're incorrect here. So we need to be sure to bring through this level at which we are certain in our conclusions, as well as kind of simultaneously talking about how uncertain we are in our conclusions. So when we did this calculation to get our confidence interval, that was with 95% confidence. So that would be something we'd want to mention in the wording of our conclusion. And it's typically something that I just say it first off in the sentence with something percent confidence. Then another piece that we want to talk about, and this doesn't have to be in a particular order, 1, 2, 3, it can be in any order. What's important is that all 3 pieces come through in the conclusion. You're going to have a range of values coming from that lower bound and upper bound. And since we're working with proportions here, those range of values will typically be percentages. So like in this case, we're going to be describing this 46% to 50% that came through with our confidence interval. Then we need to talk about what does that percentage represent. And what we need to do then is get the wording for P. So we need to describe our population parameter. So description of population proportion. So for us, it's going to be the idea of describing what's happening for all HR professionals. Our sample is just looking at 2,500 HR professionals, so we want to extend these percentages to what's happening for all HR professionals. And all is typically a word that would be coming through since we're looking at population data and describing how a population behaves. It's usually how everything behaves or all of something behaves. So we need those 3 pieces in our wording for our conclusions. And the key thing is just never mention the sample. So you don't need to mention sample size. So you don't need to mention N. You don't want to mention your sample proportion. Those are irrelevant once we get to our confidence interval. All we want to talk about are these 3 pieces. So for each of the following sentences, we'll kind of talk about why or why not can we say this if we're trying to make a conclusion for this confidence interval. So this first one says 48% of all HR professionals use social networking sites to research job applicants. So that 48%, that's our sample proportion. And what they're doing here is they're taking our sample proportion and saying it is our population proportion, which we absolutely cannot do. Even though we have a large random sample and the values are probably close to the population proportion, we don't know if it's the same number. So with this, it's saying that those two proportions are the same, our sample proportion and population, which is not true. So no, we cannot say that. That's kind of a misuse of our sample proportion. Then this next one says it is probably true that 48% of all HR professionals use networking sites. With this, it's still trying to equate our sample proportion. And basically, since it's even mentioning p-hat, it's an immediate no, because we shouldn't be talking about our sample proportion in our conclusion. This one's a slight, it's not an improvement because it's still pretty bad, but in terms of comparing it to A, B is slightly better because they add this kind of uncertainty, which is something we should have with our confidence intervals, kind of this level of certainty and uncertainty. However, it's still working with that sample proportion, so that's also no good. With C, they say, we don't know exactly what proportion of all HR professionals use social networking sites to research job applicants. That's pretty good. That's true. We don't know exactly which. But we know that it's between 46% and 50%. So now they're bringing through our confidence interval. And if we were writing this, we'd probably want to throw in a little more accuracy with a 46.04% and 49.96%. But some good things here. They're saying we don't know what it is, but we have this range of values. So in terms of the pieces we should mention, this covers 2 and 3. What we're missing is a level of confidence. Or actually, they even kind of throw in a level of confidence by saying, but we know that it's between those two values, which that phrasing is linking to 100% confidence. They're saying, we know it's between those two values, but we don't know that. We're very, very confident it's between those two values, but we can't say that with 100% certainty because maybe we did get a weird sample. Maybe that initial 48% we got isn't a good estimate for the population. So we can't say this with 100% certainty. So no. And we won't have confidence intervals with 100% certainty. Just doesn't happen. D kind of goes through very similar wording. The only thing that changes is that it's probably between those two values. It's better, but still not great. Basically, to get this interval out, to find 46% and 50%, we know what level of confidence that we had. So this is just too vague. Just to say it's probably doesn't give us an exact value of certainty. So no. But then this last one, we're 95% confident. So there's the first piece we always want to see, our confidence level, that between, and then we have our interval there. Again, we probably just want to use those more exact values to make it more accurate. And then those percentages are for all HR professionals. So then they describe this proportion for our population, and this is perfect. That's what we want to see. Those 3 pieces, any order that makes sense, but that would cover everything we need. So of these, only one works. So you just want to be sure you get all 3 pieces, that you're not too vague with describing your level of confidence, because we're always going to know this exact level of confidence that we have. So that's how we work with wording our conclusions. Now, to make our confidence intervals, we need these critical z-scores. So that value z star that we saw in our formula before, and that value z star is coming from taking our curve and our curve for z-scores. So we'd be taking our standard normal curve, and we want to take that curve and center our percent confidence. So z-scores, And in terms of confidence levels, typically we'll always work with these 4 confidence levels: 99%, 95%, 90%, 80%. So once we find these critical z-scores here in this video, you can write them down, and they're the values that we'll keep going back to. Now, you don't have to find them every single time. The only time you would need to go and find a z-star value is if we suddenly do a confidence interval with a different confidence level than we see here. If I suddenly said, find an interval with 86% confidence, then we need to go through these steps again. But let's go ahead and look at how we would find these values for our different confidence levels. So, if we're looking at 99% confidence, this would be the idea of taking a curve and putting 99% in the middle there. And what we want to do is find this z-score. That z-score for this curve, and centered at 0, standard deviation of 1, that z-score is going to center 99% between it and its negative value. So again, with GeoGebra, we can't find these centered areas. So instead, what we're going to want to do is think about the tail areas. So overall, there's this 1% left over to make up our 100%, which means there's going to be 0.5% in the left tail, 0.5% in the right tail. So we're just using symmetry here to figure out what's in the tail so that everything adds up to 1. So now with this information, I can go into GeoGebra and figure out where's a cutoff on our standard normal curve such that the area to the right will be a 0.005, and that will give me the z-star value. So if we go to GeoGebra, find an area to the right, and we want an area to the right of 0.005. And that's a 2.5758. So if we want to use a 99% confidence interval, that's the z-star value we use every single time. For 95%, we actually found this in the first video. So for 95% confidence, we'd have our curve and we'd center 95%, which leaves us overall 5% in the two tails, but if we split that up, it's a 2.5% in each tail. And this is where we went to GeoGebra in the first video and got out 1.96. So whenever we do a 95% confidence interval, that's our critical z-score that we want to use. For 90% confidence, same idea. We would take our standard normal curve and we'd put 90% in the middle, which means we have 10% left over. Split that in half, there would be a 5% in each tail. And over here is our z-score. So we want to find this z-score such that 5% of data is to the right hand side. So we just need to change this area to the right to 0.05, and that's 1.6449. So if we ever need a 90% confidence interval, that's our critical z-score. And then for 80% confidence, we would put 80% in the middle of our bell-shaped curve, which leaves 20% left over, meaning there'll be a 10% in each of the tails. So our z-star is going to be this cutoff point such that 10% of data is to the right-hand side. So in GeoGebra, area to the right, just change that to 0.1, and that's a 1.2816. I will say 80% confidence isn't very common since that's a pretty low confidence level to have. So definitely these first three, 99%, 95%, 90%, much more common, especially 95% is very commonly used in the real world. So with that, you can copy down those z-scores, and if you're ever asked for any of these different confidence levels, that's your z-score, and you don't have to find it again. Just have it written down somewhere in your notes so you can just refer back to it, then you won't have to find it again. But if I did throw in, say, find an 86% confidence interval, what you do is put 86% in the middle of your distribution, figure out what goes into each tail, and then use GeoGebra to find that critical z-score.